Hello, everyone, and welcome back to the Practical Python Application Series, where we take the concepts and the videos in our fundamental playlist and integrate them together to create an actual application that you might see in the real world, or at least a starting point for such an application, uh, all from scratch. So in this case, what we're going to do is we're going to take our centralized ledger we built in the last one, and we're going to add in networking components so that it works on a client-server model using sockets. So if that sounds interesting, stay tuned. All right, so before we get started, we're just going to go through again and take a look at exactly what we're working on this time. So this is similar to what we looked at for the requirements for the last video. Again, if you haven't seen that yet, since this one does directly build off of the previous video, I'd encourage you to go ahead and watch that. I'll put a link in the description. But here highlighted in green is the main changes from what we've already done. So we're still going to have a centralized ledger that performs all of the same operations. The only difference here is that this time it's going to act as a server on a physically separated machine. And again, in particular, we're going to use an AWS EC2 instance. Now, the only concept that I have not shown so far in my fundamental applications, at least at the time of this video, is creating an instance on AWS. If you get lost at that point and you would like to see a video on that, just leave a comment below and I'll try to get to that. AWS EC2 is not required. You can use any other cloud instance, or you can even host a server on another machine that you own. So this is not necessarily required for this. It's just to demonstrate some place that is physically separated in this particular example. Then we're also going to have user nodes, which are basically doing the same thing. But again, they're going to be on a physically separated device. In this case, they're going to be our clients in our client server model. Concept here of our flowchart is still the same, except everything over here will be a client, and technically each of these clients could exist on their own device. The ledger itself will exist on the server, so the server.py file is going to exist on an AWS EC2 instance, and it'll, instead of sending this information back and forth by interacting directly with the ledger.py file, as we did in the first video, since they were physically located, just importing the file, we're going to actually send this information over the network and interpret it on the server to determine exactly what needs to be done. Again, some other future work that we can get to at some point. If any of these are interesting to you, you can go ahead and leave a comment and I can show you how to do those. Otherwise, if you want to go ahead and work on them on your own, and send me a link to your GitHub repository and let me have a look at it, give some feedback, I'm okay with that as well. So with that, let's go ahead and open up Visual Studio Code. So what I have here is the file, or the files in this case, that we had last time. Again, if you haven't seen the last video, I'd encourage you to watch that so you can get caught up. And basically what this did is it used it locally with a node and a ledger file, and the node itself would just import ledger directly and call the different methods on the ledger file. Now in the client server model, that's not going to be possible because the ledger file won't necessarily be directly connected in our instance. So what we need to do is add some changes here so that both the ledger and the nodes use the socket library, which we had in one of my recent videos. Again, put a link in the description if you want for that. So that the node itself will establish a connection to the ledger, and then instead of just calling, ledger.queryBalance, will send a message to the server, which will call its local query balance function. and then return the result back to the client, which will then print it. So first thing we're going to do here when we get started is we're going to import socket. And I'm actually going to rename this from node 1 just to client. It doesn't necessarily need to be called client, but it's a pretty good naming convention. And I'm going to change ledger.py to our server. Right. Now, we don't necessarily need these import statements. When I delete this, it's going to cause an error because it no longer understands what server is. And you saw that pop up. That was basically refactoring, and everywhere that it originally had ledger, it replaced it with server. This is good here that it underlines it because we'll know some of the areas that we need to update. So thinking of our server and our client model, if we remember back from our video, and again, I need to import server here, or import socket. So the standard process again is, creating a variable to hold our socket instance. All right. So again, we covered these in our socket video, but essentially we're just creating an instance of the socket. We're going to have it bind to a particular IP address. In this case, since it's going to be hosted on AWS, we want it to be able to bind to essentially all the IP addresses available on that server. So we can do that with 0.0.0.0. And let's give it a port. We'll call it, like we did in the previous video, 5555. And then we need to set it up to listen. In this case, we'll have it listen up to 5. We can have any number if we want that our server will support, but we'll just do 5 for now. Okay, so now we'll also need to make a similar change to the client side. So we can copy some of this here. All right, so again, on the socket side, we need this same line here, but instead of connecting or of binding, we're going to do a s.connect. And in this case, we need to know not 0.0.0.0 because that's going to connect to our local, every instance. So we definitely don't want to do that. But we're going to go over to our AWS instance that I've set up. And I'm going to grab the public IP address of that. And paste that in here. So now it's going to try to connect to that server using that port, which I've set up to be open. And then we don't need to do the listen on the client side. So this will now try to establish a connection. If I run this now, it's not going to do anything because that server only exists locally on my machine. So at some point, we're going to have to go ahead and get it onto the server. There's a couple different ways we can do that. We can use a GitHub repository and upload the code. We can also just open up an editor on the virtual machine that is created on AWS and paste in the code. So we'll determine what we're going to do at that point when we get there. Okay, so now on our client, we do want to have similar concepts here. We're going to have the same concepts of, okay, checking the balance, sending to another, or quitting. Okay, so this is good to go here still. Inputting the name. So we can actually make a modification here on the client side, and we can create a client file. which is basically has all the information for the client themselves. So what we could do is I'm going to just create a new file over here. And we'll create a new method here to get the client details. Okay, so first thing we're going to do here is we're going to open that file we just created. In read mode. All right, so once it's open, we're going to get the content. We're going to read it, and then we're going to close it. Now we can do an if statement, and then just say if there's nothing inside content, then at this point, we're going to get the username, and we're going to prompt the user. And then once we have that, we're going to store that information back into the file. And there's multiple ways that we can do this. This is just a simplified method of if there's something in the file that has a client name, we're just going to go ahead and continue with it. Otherwise, we're just going to grab the first line and then use that as the username. So let me see if I can actually read lines instead. And so when you do read lines, it puts the content into a list. So if the value of content at 0 is that, then we know we don't have the name. Otherwise, and again, this makes a few assumptions that the client file has not been corrupted. We can do other things in this case where we incorporate digital signatures, and the digital signature is used as maybe a hash of the digital signature is used for the name for the user. We can have the file password protected, but ideally you would only have one client instance on a machine. You wouldn't necessarily go ahead and delete it and modify that file itself. But again, that's something that we can look at as future work. How do we protect the integrity of our system on the client side? But again, just to keep this video short and for at the beginner level, we'll make some assumptions at this point. Okay, so now we're going to open it and we're going to write in this case. And we're going to write in do f.write. Then we're going to use username. And we'll close it. And then we'll also return username. So in this case, whether we have nothing in there and we enter a new username, actually, the writing is going to go in here after we get it. Here, username is equal content of 0. Okay, that's good. Either way, we get a username variable and then we return it. Okay, so we get the client details. And now let's do a method to get the balance. So def get balance. And in this case, what we're going to need to do is, since we can't call this query.getBalance directly, what we have to do is create an instance, a connection to the server. So in this case, we've already have this connection, this S. So we'll need to do s.send Again, we can either put in a B and then our text to make it a byte string, or we can create a message and then we could say get balance and then, well, in quotes. So what this is going to do is we're going to create a method or a value a variable here, and message is basically going to include get balance underscore and then the username. So if our username is Bob, it's going to include that. Okay, so we're going to send our message dot encode. Again, so that it gets sent as bytes. Okay, now we're going to take a break from the client right now because we need to have something on the server now to get the balance. So on our server side, our server is going to be continuously running. So just like we did in our previous video dealing with sockets, we're going to have a while true. So our server runs forever. We're going to create a client socket variable and an address. And both of these get returned when we call s.accept. I need a comma. Okay. So at that point, we're going to have a connection with our client that's connecting to us. And then we're going to expect to receive some type of message from them right away. So we do that with client sock.recv for receive. And we're going to get the value that they sent to us. So at this point, we know that they're expecting a message for the client balance. Now, this will create some confusion because we don't necessarily know exactly the size of that. So we can, do something ridiculously large in case it has a huge name. But again, this doesn't necessarily take into consideration all the different possibilities that we can receive from the client. So we can actually establish a protocol here of expected communication back and forth. So instead of first sending get balance in the string, the first thing we're actually going to send is a message. And then we're going to say, if the message type is, message 001. So we'll say MSG underscore 001. And we're going to have, let's see, that's 3, 6, 7 characters, 7 bytes that are going to be sent. So what we're going to do in this case is every time we send a specific message type, that first message coming from the client is going to be exactly 7 bytes long. And then we could have another message, MSG 002, MSG 003, etc. And that's going to kind of set the stage for what information we're going to send to the server so the server knows how to respond. So we'll do kind of the same thing here. All right, so we're going to send that. And on the server side, we'll go over here and handle it. So we'll start up with, again, receiving the message here. So we always know the first thing we're going to receive is exactly 7 bytes long. Now, if, again, we need to save this as a variable. And at that point, if we know the message.decode into UTF 8 is equal to MSG underscore 001, then we're going to do something. So in that case, we're going to call our get balance function, or at least set it up so that we're going to call our query balance function. So what we can do once we receive this, we can, since we're using TCP, we can, kind of do an acknowledgement. So we can say client sock dot send, and then we'll do it as bytes, ACK 001. So we're acknowledging we send 001. So that means our client must expect that to come. So we left down here. So when we're calling the get balance method, now we need to set up our client to receive that. So we'll get our response equals s.receive. Again, in this case, we're receiving exactly 7 bytes. And we can do the same thing of if response dot decode equals acknowledge underscore 001. Then in this case, we can move on to the next step. So our message then becomes here, message equals get balance string and username. But before we send that message, we're going to get the length of it. And we'll say message length equals len of message. Okay. And that's going to be the first thing we send so that they know exactly how much of a buffer to create for our client. So we're going to s.send message length. Actually, we're going to want to have this converted to a string because it's going to be an integer. And then we're going to take that string and encode it and then send it. So we know we'll have the message length here. That means a server must be expecting that server, the length as the next value. All right, so what we're going to do here is same as we did before. We're going to recv. And in this case, it's kind of a chicken and the egg problem. How do we know exactly how big the length is going to be? At that point, you can kind of assume that there's some protocol in place that a length isn't going to be exceptionally large. Remember, in this case, we can have any number of values being sent. It can be 3 digits, it can be 100 digits, but we'll assume that at most that there's going to be, you're not really going to have more than a 10-digit long, 10-character long number being sent for the length of this file. So we'll do client sock dot receive 10 socket. All right, and now we need to convert that to an int. And convert it to an int. All right, so now we know the length of the next value we're going to receive. So we're going to do a client socket dot receive again. And we're going to pass in the message length. And of course, we need to save that into a variable. So we'll call that our message that we're actually trying to receive. And we'll decode it. Now, we're expecting it to be, in this case, get balance underscore and then the name. So what we can do on the server side is break it into a couple parts. So say name is equal to message dot split. I'm going to split it on the underscore. Now that's going to create a list or an array of values with everything on the left of the underscore and everything on the right of the underscore for each underscore it found. In this case, is only one underscore, assuming that the name itself doesn't have an underscore. Again, one of those assumptions that you may incorporate into the creation of an account. Now, it's since we only want the right half, we're going to want at the index 1. So index 0 is going to be the first part, and then index 1 is going to be the name. Now, with that information, what we can do is finally call our get query balance method. So let me just move it above here to make it a little bit easier. All right, so now we're going to call query balance. We're going to pass in name, which should be on the ledger. So it's going to open up ledger.txt, which again is still going to exist on the server. And then it's going to return the balance. So we need to capture the balance. So similar to what we have before, where we kind of needed to understand the length. So in this case, you can assume that if the starting balance is 100, that at most you're probably going to have a 4-digit or a 5-digit number. So you can make that assumption, or you can incorporate, similar to what we did before of getting the size of the balance and how many integers it is, or how many digits the integer is. But in this case, we'll simplify it again using assumptions and assume that the balance is never going to be more than 6 digits. So we're still down here and getting the balance. We've sent the message. So the next thing we're expecting at this point is the balance itself. So we're going to do s.recv, and we're expecting it to be no more than 6 bytes long. And we need to save it as a variable. And now on the server side, we need to make sure we send that. So we're going to client sock or client socket dot send, and we're going to take our balance, which could be coming in as an integer, but we'll make sure it's a string balance dot encode UTF-8. All right. So now we should have the balance come back to the client, and at that point, we can print out the balance. So it'll just print out a message for what the balance is. Let me comment this out for now. Okay, so we have get balance into a method here. So down here is really kind of the starting. So we have the menu display. This code is still the same. If we get 3, then we'll quit. If response is equal to 1, we're going to call not server.get balance, but we'll call our own get balance method. And then we'll pass in our username, which do we have? We need to call get client details first. So now we're storing our username in memory. And then the client continues until we hit 3. And then we also have this section to send a transfer from one person to another. So let's look at that part next. So transferring value, what we previously did, let me move this up here now. Okay, so basically we took a from user, a to user, and the value. So the concept here should be pretty similar to what we did before, except all of this right now is under the message 001 type. So we need to do the same thing, and we'll just call this a message 002 type. We're going to do the same thing and do an acknowledgement for message 002. And on the client side, we'll do something similar. So we're going to create a method for transfer. So we need a from, to. Actually, we should just need a to name and a value. Actually, and we'll also do a from name. All right, so in this case, we'll start off with, it's going to be message type 002. Send it, and we'll get the acknowledge back. Okay, so far so good. All right, so now if we're going to transfer the information back and forth, so we need the from user, to user, and the value. So we're going to pass those values to the user. So in this case, we're still going to get the to user. The from user is going to be the username, and then an amount. And we called our method here transfer. So that'll move us up to here. And we're filling in the to name, from name, and value. Okay, so our format for our message here is going to be our to name, from name. Well, let me get rid of the underscores here to make it a little bit easier. And our value. So an example would be Bob underscore Alice underscore 100. Okay, so in this case, we need to, again, get the length of this message. So we'll first create the message. We'll convert it to a string just in case, but it should come in as a string. Put in an underscore. All right, so we need to get the length. Okay, So we get the message length, and we'll send that to the server side just like we did before. So let's see how we did that down here. Just like we did that. So the server is expecting the next message to be the length. Okay, and down here, again, we're expecting the length. So in this case, it is a little bit harder because we don't necessarily know which, how long the first name is, how long the second name is going to be, or the value. So this could be one of those where we make an assumption. Let's say we have the assumption that a username is going to be no more than 15 characters each. So if we have 15 plus we have a max value of 6, so that's a 36. So again, assuming the max buffer size we can have here, if all of those are maxed, then we're going to set the acknowledge. Okay, we're going to grab the message length. So we get our message length is equal to 36 bytes. Again, assuming 15 bytes as the max size for the first username, 15 bytes for the max size for the other username, and then 6 bytes for the max size of the balance being sent. And then we convert that to an integer. Oh, we have a indent issue. Okay, so now we have the message length. So we're going to receive that message length. So on this side, actually, if we're going to assume the max length there, now we can keep it that way for now. So we send the message length, and then once we send the message length, we're going to actually send the content of the message. All right, so we're going to send the message.encode. And on the server side, we need to receive that. So we'll receive that size. Excuse me. And now we have all the information we need. And we're going to do the same thing. We're going to decode it, and then we'll do a split. But we're not just looking for one piece here. So we're going to say our to name is at index 0. Our from name so it's well, actually, let's make it easier so I don't have to split it each time. So we'll say split message equals message.split. And now I'll just do split message. So the 0 index of split message. Then we'll do the first index of split message. And then the value is split message at index 2. Now I could pass those directly into the method here as well. So what I'll do is I'll transfer value, call that method. And again, we're passing the from, to, and value. Okay, so we have all that. This. And for now, I'll get rid of the initialize code for now. We can add that back in later. Okay, let's see if anything else is missing here. I believe it's correct now, but we'll test it out here once we move it up. Okay, so what we're going to do now is I'm going to go into my instance here. So this is my AWS instance. It's a Ubuntu box. So there's nothing really on there right now. So I could go through the process of uploading the code to GitHub and then downloading it. But at the same time, what I'll do is I'll open up an editor. So I'll use VI and I'll call it server.py. And what I'm going to do is take all the code in server, copy it, and I'm going to, for VI as a editor using the terminal, I need to hit I to make it go into insert mode. I'm going to right click and let's see, did this mess up formatting? And then let me do an escape, colon WQ for write and quit. Let me do cat server.py. And it's got the indent error. Okay, so what I'll do here, maybe I can open up a notepad. See if it'll get rid of some of that formatting. So I just deleted the existing one. Okay, so that's not going to work the way I expected it. So what I can do instead, let me just go ahead and do the GitHub. So let me make sure Git is installed on my server here. Okay, I do have Git already. So what I'm going to do here is I'm going to create a GitHub repository. So again, I had a video on this as well. I'll create a new repository and I'll call it server demo 1. I'll make it private for now. All right, and what I could do here is add files. So I can either, go through the command line or I can drag and drop the the code themselves, the content itself. So let me go ahead and get to the location. All right, so what I'm going to upload the server code. Just drop it in there. Then I'm also going to upload the ledger file. Call this initial commit. And now those files are there. Now I also need to go into the settings, developer settings, and create a key here. Just give it everything here. Again, this is just going to be deleted at the end of this, so it doesn't necessarily matter. All right, so I have the token here. All right, so now I can go back into here, and we need to do it. Let's see what else is here. So let me remove our existing server.py. And what I'm going to do is do git init. Git init. Okay, so I created a initialized repository here. Now we need to remote add origin and our instance here. So we just called this one demo. Let's see, server demo. Then I have a video on using GitHub as well, so feel free to check that out. I need git in front of that. Okay, so now we can git pull. And I need to grab my token, of course, which okay, grab. Excuse me. Had a bit of a cough there. So I have my token now, which I'll use as the password. So I'll paste this in here. Uh, there we go. Okay, so now we need to check out our branch. And we're calling this main. All right, so now we have our ledger and our server file running locally. So I'm going to, well, I'll keep the ledger file for now. So we'll do vi server.py. So I just want to make one quick change here and just print out that the server is running, just so we have a bit of feedback. All right, so Python 3, again, using Ubuntu, we need to specify Python 3, server.py. All right, what did I do here? Oh, because there's an error here. I'm just passing in a string, comma, and an integer. What I actually need to be passing in is a tuple. So surround them in a set of parentheses. Let's try it again. So the server is now running. Great. So back on our local code here, on our client, I can actually delete our ledger file here. We don't need it anymore. This new file, I don't need that anymore. I don't even need the server file anymore. All right, so client details, there's nothing in here. And I need to make a change here to make sure this is a tuple as well. And let me launch a terminal. So now, assuming everything is correct, we should be able to reach out to the server and get the information. So Python client.py. All right, let's see what happened here. So we start up here, we go to get client details. Okay, so it didn't like the fact that this is empty and the way that we're checking it now. So what we can do instead, we can say, instead of content, that first one is 0, we can say if the length of content and that should do the same thing, basically saying if it's empty. Let's see if that works. Okay, so it did get past that. It didn't have anything in there, so we're going to say Bob. If we look at here, we do see Bob is now added there. So we want to check our balance. Again, we uploaded the ledger file with some data already in there, so we should get something back. Okay, so we got B0. So let's see what's going on here. Okay, so we have an error here. BI server.py. All right, so the error was in our get balance. Let me exit out of this and see exactly what line this was on. So it was on looking for message 002. Okay. So we're looking for here. So we're sending that. One second. always a problem with coding live. There's always unexpected errors that occur. Okay, so let me take a look at this. So we're getting our message, we're receiving it. Message dot decode UTF-8 equals message 002. Five. So I'll just make a change up here. Oh, I need to insert. Okay, we'll just say and then I'll change this to message. And down here, same thing. All right, let's see what we got here. All right, let's try this again on here. All right, let's see if the server broke. Okay, so we got past that. Let's do for good measure logging here locally. We're just going to print out what we receive just in case we're missing something. Okay, so this is an error that sometimes comes up if you have the server crash or stop unexpectedly. Then when you go to use it on the same port again, temporarily you get an issue where it's already using that port until it kind of recycles itself. All right, so let's try this again on the client. We're going to check our balance. And I think I know what the issue is here now that I look at this. So it's saying we received message 001. Okay. So on the server side, let's take a look at our code. Again, this is an example of coding not always being as straightforward, but okay, so we know we're getting message 001 at this point. And we're getting our message length. And while I close this, I think it might actually be working as expected. It's just yeah, so maybe because we have our name as Bob with a capital B, but there's no balance with Well, there is a balance here going to Bob, but let me see what happens here if I change our client details to Bob with a lowercase b and relaunch our server. Okay, so still not getting expected results. So let's add some more logging in. So let's print name. And then once we get to get balance, let's print our balance as well. And so we just need to wait for our server to recycle itself. Okay, so we got something wrong here. So our name is coming up as balance. So let's see what's happening. So on our client side, we should be sending so get balance in string username. Okay, so we're receiving this message A equals get balance. I think this is because it's not indented here. Right on the client side. Let me see what we're actually sending on our client side. Okay, so that's the issue here. Should have saw this. So our message is get underscore balance underscore Bob. But in the server side, you know, it's only taking.
Answer your question. As a verb, no is usually defined as to proceed.
Okay. Sorry about that. My Alexa went off. Okay. So what we need to do here is vi server.py, and we're splitting the message here. Instead of at index 1, we need index 2 because we have 2 underscores there. Okay, so we just need to wait for that to clear up. Should recycle itself here in just a second. There we go. All right, and now we see his balance is 120, which is kind of what we would expect there. The only difference is we're getting string balance here, but let's decode it so we don't get that bytes in front of it. So now we see it correctly as 120. Theoretically, we could try to send to another user. So it's getting caught up somewhere. So there's an error. So what we're doing is we're calling transfer. We're sending message 002. So it hung up. All right, so we got, let me see if the server's still running. Okay, so we're sending 002. Okay, so our message is from Bob to Bob. Okay. So what might be happening here is the connections are timing out, because one thing I didn't do here is so we established the connection in the beginning. We run it, we grab a connection, but we never actually close the connection. Actually, we should probably close it on the client side. And then we can have it set up to actually make the connection each instance. And now if we're going to do any of these, then first thing we'll do is connect. And actually inside of each of these, I'll close it instead of on the bottom. So we get the same thing there. So let me see if I can try again. So we see that worked properly. It was the connections not closing properly. So what we did, we were successfully able to send from Bob to Alice because Bob had a balance of 120. He sent 10. So then after we checked it again, he had 110. So this was a little bit longer than I expected. We ran into some problems, but you also got to see how, I go through and try to debug problems on the fly, which is something you'll have to do in the future as well. So hopefully you actually got some value out of that. Um, more videos like this are coming. If you'd like the format, if you'd like, I can, have any suggestions for how I can do this better. I'm always trying to improve. This is still a young YouTube channel, so I'm looking for feedback. So feel free to leave a comment below if there's something else you'd like me to go through and demonstrate in a future video. Again, comment below. If you like this content, please like and subscribe. Other than that, for now, that's all I got.
Good news, everyone.
That's right. Good news, everyone. This is Doc here. You made it to the end of the video, which means you liked it. So please click on the thumbs up below the video. If you have any comments, anything else you'd like me to see put a video together for, leave a comment, ask any questions. And of course, more videos like this are coming, so be sure to subscribe.